In this video, we're going to be going through an example of line of best fit. Before we do that, we're just going to review some important concepts. So example 1, describe the relationship and trend in each of the following. So the independent variable is, in this case, it's the age. And we know that because it's on our horizontal axis, also sometimes known as an x-axis. And in this scenario, we're talking about age versus height. Age would be our independent because that happens independently. And then height is on our vertical axis, or sometimes known as a y-axis. When you look at the trend of the points, you'll notice that the way I read it is this way, from left to right. You'll notice the points are going up to the right. This scatter plot shows a positive relationship, or we can call it a positive correlation. And when we describe the trend, it's easiest to start with the independent variable. So if I look at the age, it's going increasing. What's happening to the height as well? So as the age is increasing, the height is increasing too. So as the age increases, the height increases as well. So the next example, you'll see the scatter plot here. I can't describe it as any trend because the points are all over the place. First, let's talk about it. It has to do with time travel to school versus height. Well, I can already tell from the title that there should be no relationship. The independent variable is always on our horizontal. And our dependent is always on our vertical. So the trend is, there's no trend, no correlation. There's no way that I can describe it as going up or down. And the last example is to do with temperature versus depth in a lake. So again, we're talking about the depth, that's what's happening. So you're independently going down into the lake. You're deciding how deep you want to go. And then you're dependent on the vertical axis is the temperature. Now remember, so the deeper you go into a lake, the colder it's going to get. That's why you see the points are going, the way I read it from left to right, the points are going down to the right. The scatter plot shows what we call a negative relationship or a negative correlation. The trend is as the depth increases, so always start with the x variable or the independent. You're always saying that that's pretty much, you're always saying that that's increasing because you're moving to the right. Okay, so let's look now at our next example. Before that, let's talk about what is line of best fit. So it is a line that shows an approximate trend, so you're estimating with the data on a scatter plot. It shows the pattern and direction of the points, so when you draw a line, you can see the direction it's going. And most importantly, it helps us make predictions. That's why we draw it. We can make predictions of what's happening. Well, what happened. So two main important rules. It passes through as many points as possible. There's the same amount of number of points above and below. So you want to approximately have the same amount of points above and below. And also don't forget that it has to follow the trend. So you don't want to draw the line the wrong way. So if it's positive, it's going to go up. If it's negative, it's going to go down. So example 2, which line is the best would you use as a line of best fit? So in the first one, you can see that it's a little too high. There's not enough points above and below. So this one I would not recommend. This one looks pretty good. It goes through some points. It looks like there's approximately the same amount above and below. And this one, you can, obviously, it's too low. So this one, this is the best. Okay. So this is the best line of best fit because it seems to have an equal amount of points above and below. Let's see now. Draw the line of best fit. Okay, so you're going to take your ruler. I'm going to place a line and then move it accordingly. It's obviously going to go upwards between the shoe size and height. So once at some point you will actually be doing a let's see, is that working out? So you put a clear ruler is best because then you can move it accordingly. 2, 3, 4, 5, 6. 3, 4, 5. 1, 2, 3, 4, 5, 6. So looks about right. Okay. It's going upward. I have an equal amount of above and below. And it'll help us make predictions. So let's say I wanted a point in between here. I can predict when a shoe size is a certain amount, what would the height be? So again, do the same thing. Put your ruler and then move it accordingly to try your best to get an equal amount. So this one's going downwards, the trend. So I don't have an equal amount of points right now. I have 5. Oops. 1, 2, 3, 4, 5. 1, 2, 3. Okay, so that looks okay. Get rid of this one. That was. So this one, as the temperature increases, the soup sales decrease. And the last one, I can't draw a line because it'd be possible to draw a line upward. It'd be impossible to draw a line downward. Okay, just use. So you can see like a line downwards, but what if I draw it upwards? Where's the trend? There's no trend. Okay, so keep that in mind. I'm going to see that pen disappear because it's wrong. So there's no trend, so it's impossible to draw a line of best fit. Ah, my pens. Oopsie. So there's no trend. Therefore, we are unable to draw a line of best fit. Okay, so the next one, example 4. The table shows the world record for women's 500 meters skating from 1983 to 2001. Draw a scatter plot and a line of best fit. So the scatter plot's already drawn. Remember, this lightning bolt just shows that we're skipping. We didn't start at 0 for both of them. We have the years from 1981 to 2005, from 0 to 40. Time. And you can see the trend is going downwards. So as the years are going by, people are beating their records and it's going down. So let's draw a line of best fit. Draw the line. I can move it accordingly. So put your ruler and try to move it. Gone through quite a few points. Okay, so it doesn't have to be exact. So I think I'm have one point really close, a couple, and then 4 above and 3 below. So that's pretty good. I'm gonna extend my lines, so I can make predictions. So our line of best fit's all gonna be the exact same? No. There are some analytic ways that we draw these, but that is for a higher level of learning. So the independent variable here, again, it's going to be on the bottom axis. So it's the years. And the dependent is time. So you'll notice that as the years go by, so as the years increase, the time is decreasing. Okay. We call this a negative correlation. So as the years increase, the time decreases. Well, the record have been in 1981. So if you look at 1981, and look, it's a little bit above 40. There's 2 tick marks, so that's 40, that's 40.5. So I'm going to estimate 40.3, and it's in second. So it's going to be approximately the same. And then it says, when might the record have been less than 37 seconds? So let's see, 37 seconds. Go across. So this is where you're using your line of best fit to make predictions. So approximately oops, maybe that wasn't a good, I didn't go across enough. So approximately 2002. So after 2002, it would have been less. And there you have it. Line of best fit and how we'll use it to make predictions.